I'd like to introduce our experts, Charlie Baker and Josh Snowhorn. Charlie Baker is Dine's Director of Product Management, Internet Intelligence. In his role, he oversees the roadmap and strategic direction for Dine's Internet Performance Services. Prior to Dine, he was a Director of Product Management for companies like Bricks Networks, which was purchased by EXFO, and Brooktrout Technology, which is now Dialogic. Josh Snowhorn is VP and General Manager at CyrusOne. He also currently serves on the Board of Directors for the Open Internet Exchange and is the co-founder and current board member of the Global Peering Forum. He brings 15 years of data center and interconnection experience to his role. He and his team have designed and implemented the CyrusOne National Internet Exchange strategy to significantly increase the number of telecom and cloud providers available to customers. Prior to joining CyrusOne in 2012, he spent the previous 12 years as VP at Terramark, a data center and cloud services provider acquired by Verizon in 2011. And with that, I'd like to turn our presentation over to Josh to get started. Josh?
Well, thank you for the introduction. And welcome everybody to this great webinar. We'll be able to teach you great things about the cloud and interconnection in the world. As was previously stated, I'm the VP and GM of Interconnection at CyrusOne, and have a strong focus on creating interconnectivity for our big enterprise customers. CyrusOne is really stated as the preferred data center provider to the Fortune 1000. We have a massive number of Fortune 1000s, over 160 in our facilities today, and over 900 customers with the inclusion of our recent acquisition of Servalis in the Northeast and their data center and financial industry customers. Our company trades on the NASDAQ under the symbol CONE, and our environment is really focused on production data center and disaster recovery data center for oil and gas, financials, and any enterprise who has high availability needs and demands throughout the world. Our data center focus is throughout the state of Texas, Illinois, Ohio, Northern Virginia, the Northeast, and a very large facility in Phoenix, Arizona. We also have facilities overseas in London and in Singapore of a smaller size that we lease from other third parties. Our major facilities in North America in scale are going to be throughout the Ohio Valley. We have 875,000 square feet. In Texas, in Dallas, our headquarters is 668,000 square feet. Our Houston West facility is 700,000 square feet. And our Phoenix campus, at full build-out, will be almost 1 million square feet. So scale is quite important to CyrusOne, and if you note the adjacency to large Fortune 1000 infrastructure and headquarters, it's always crucial for our customers. A big focus for CyrusOne is always servicing enterprises, but all of those enterprises have to have adjacency to different services, and that might include cloud services with Google or Amazon or Microsoft, access to Facebook and social media, Twitter, YouTube for videos and delivery for things like webinars that might get played again on live video feeds, and everything else you can imagine. And all of that is scaling at a rapid click. If you think about the global internet, and what an enterprise might use previously, they were very happy to buy a telecom service from any major telecom provider, really not looking for much network intelligence, something like Dime might provide, and instead they would just buy those services and really just connect their facilities and be happy with their localized internet. But the world has completely changed now. Enterprises are now focused on driving access to cloud and various content, replication between data centers, and the enterprise network architect is a highly strategic and educated individual, where previously that person might have had a focus on IT, that focus now is on a global internet infrastructure. If you think about the global internet, it's really all interconnected, not with satellite, but by undersea cables. And this is actually a top-down view of the world's undersea cables. This is an ever-expanding map. But if you actually took out these very specific links in any way, shape, or form, then you would lose connectivity anywhere in the world. However, being the internet and the way packet architecture works, it would just replicate out the other side. Now, you might have added latency and other things like that, and it's very important to choose carriers who are going to have the most resilient path, not just on a single route going maybe from the US, say, to Asia, but also Europe throughout via the Suez Canal and then back to Asia again to make sure you have the complete resiliency. But all of it connects with undersea cables, or domestically, it's going to connect with fiber optic backbones. And if you can look at all these core cities and all of the maps you see here, this really looks like a highway map, or if you think about rail lines or maybe natural gas lines, these are all the exact same routes. And if you note on this map, you'll see aggregation of fiber optic cables in very specific cities. Those interconnection cities are going to be in Silicon Valley, Los Angeles, Seattle, Dallas, Chicago, Houston, the Northeast and Virginia, various sites in New York, Boston, Atlanta, and Miami. And all of that really just follows these fiber optic cable routes to deliver that access. Now, enterprises are getting much more intelligent in looking at these maps and making sure they have resilient backbones around the country and not just taking an answer of, yes, it'll work. They really want to see these maps and make sure that resiliency is delivered. Additionally, that concern relates to latency. And if you think about data replication, and all these red dots on the map actually represent Fortune 1000 companies and their headquarters, you can see where these circles converge, you'll actually be under a 5 milliseconds latency bubble. And it's very important to locate data centers within that bubble to make sure you can do active replication or active-passive to meet certain needs for large SAN environments and things like that. Additionally, this is very important for cloud providers to locate infrastructure in these locations and have large-scale network feeding those different cloud network providers. A way CyrusOne does this is using our National Internet Exchange platform. What we do is we link up major network facilities from our data centers within a metro throughout the country, and we tie that together with the most resilient network providers going city to city across the country. We use our carrier partners to do this, but we do this very strategically. We look at their fiber maps, we look at adjacencies, we make sure nobody shares a fiber conduit or a sheath or anything like that. We look at the most resilient access, not just to corporate headquarters, but also to different cloud providers where they actually have those large server deployments to make sure our enterprises are completely satisfied with their needs. An example of that is a market in Dallas where we interconnect our headquarter facilities in Carrollton to our Louisville facility. Both of these are located in northern Dallas. Between those two facilities are about 1 million square feet. And we link those back to the InfoMart building and to 2322 Bryan, which are two major carrier hotels in Dallas. If you look at our Louisville location, where we have a large number of carriers, and then you look at our Carrollton location with a large number of carriers, they really pale in comparison to a site like InfoMart, which will have over 180 carriers. But that's a retail co-location facility, a lot of cloud routers there and a lot of access, but an enterprise normally wouldn't locate there. It just doesn't make sense for them. They want to go from their large-scale, multi-megawatt production environment with a highly resilient connection back to the carriers. What this does is actually breaks the walled garden, where you have a situation where a large vendor might control access to all of the major carriers in the world within their facility. By accessing that using this metro-enabled redundant internet exchange strategy, any entity within a Carrollton or Louisville facility can reach any carrier located at InfoMart or Bryan or any cloud provider. Additionally, we can actually deploy optical gear or edge switches into customers' existing data centers so they can scale up and grow within a CyrusOne location. And we can do this in various markets, and I'll give an example of that on the next slide. You can see our Houston market. We have our Galleria location, our Houston West location, and 1301 Fannin linked up. 1301 Fannin is the same example with a third-party carrier hotel facility. Our Galleria location is actually the original CyrusOne data center when CyrusOne just started as a business and is extremely full. Happens to be the most connected building in the city of Houston. However, there's no availability for any more space or a very limited amount. So to access all of that and to allow our customers to scale, we create a dual redundant internet exchange ring tying it to the Houston West campus, which is the seismic processing center of the world for the oil and gas industry. All these customers can grow, connect, interconnect, and tie together without any fear of access costs or metro costs to reach any of their carriers. Another example of a market that we have in place is our Austin market. And we have Austin 1 and Austin 2, and we're actually adding a third data center, which is about to open in that market. In that market, there is no carrier hotel. It's just CyrusOne facilities that are very, very well connected with big head ends for cable providers and lots of different content and access there. So the need to have any carrier hotel access was negated in that situation. Another example of a market we do that in is San Antonio. We have our San Antonio 1 and San Antonio 2 facilities, very cloud-enabled facilities, access to a major data center campus environment there, with many, many corporate Fortune 1000 data centers immediately adjacent to our facility. The facilities are about a mile apart from each other, so CyrusOne in this case trenched and placed our own fiber and connected it diversely into each facility to make sure any customer can access any other customer between the facilities without any high access costs for that just one single mile link. Another market we do this in is in the Ohio region. CyrusOne was spun out of Cincinnati Bell a few years ago, and as such, we have a very large presence in the Ohio Valley and northern Cincinnati. Our Cincinnati 7th Street facility is the carrier hotel for the entire city of Cincinnati and the region, and that's actually owned by CyrusOne. So linking up our northern Cincinnati Florence facility to to our Lebanon facility and Florence sites to that carrier hotel is crucial to be able to tie customers back together, allow replication between the facilities because of distance, and allow access to different networks and cloud providers that might not be available in each facility. Another market we're doing this in is in the Northern Virginia area. In our CyrusOne Sterling location, which is a brand new data center for CyrusOne, we're able to reach Ashburn Carrier Hotel campus, which is one of the most connected places on earth for content, networks, and cloud, and another carrier hotel in Reston, so we have diversity and resiliency for our customers. All this just makes it a cross-connect away for any customer to reach any other provider in that marketplace. Another example is our Chicago market. We have a Lombard data center tied back to the 350 Cermak facility where our gear is actually located within the Chicago Mercantile Exchange suite on the first floor of 350 Cermak. This major carrier hotel has access to every major cloud provider, financial industry customers, and helps facilitate interconnection from our Servalis marketplace back to the Futures Exchange located in Chicago. It allows tremendous access and resiliency for our customers, and if you note on every single slide, we showed remote customer access to be able to reach anybody within any marketplace to their existing data center back to a CyrusOne location. And that's all I have today. Charlie, I'd like to go ahead and pass it to you, and I believe we might have some of the maybe some questions for some of the customers based on my slides.
Absolutely, and thanks for the transition there, Josh. Wanted to ask a quick question to everybody. We're going to push a poll out to the audience here before we get started. Just to set the tone here, want to know what best describes your internet infrastructure as a company. Josh just detailed a lot about the CyrusOne infrastructure, and a number of you are using his hosting facilities. But I'm interested to know a little bit more about how many CDNs, how many cloud providers, how many hosting facilities do you actually use? So are you in a single data center? Do you use multiple data centers? Are you in one cloud provider like an AWS or a Google Compute? Do you use multiple cloud providers? One content delivery network like an Akamai Limelight Level 3, or do you use more than one? And while you're answering that, Josh, just a question. You mentioned 160 of the Fortune 1000 are using CyrusOne. Any idea how many of those are actually using multiple data centers within your infrastructure and distributing their content across the U.S. or the world?
Over 60% of our customers actually utilize multiple data centers within CyrusOne, and we see a huge amount of growth within those organic existing customers, particularly amongst the Fortune 1000. As they scale up, as they put in, say, an initial production environment and regulatory issues, especially in the banking industry, or just disaster recovery issues, require them to have multiple data centers, they utilize this. And they use the National IX or the Metro IX to reach different carrier nodes to be able to interconnect that. And we spend a huge amount of time working on resiliency and fiber design, still meeting that latency criteria. And as you see CyrusOne expand throughout North America, you'll note that we'll stay within certain latency metrics between our facilities.
Got it. Yeah, and we see that a number of our larger customers actually are in a multiple environment with a cloud provider, a CDN, and their own hosting for their origin. We'll talk a little bit more about the other two scenarios here, but let me just kind of see what kind of results we got here on the survey. So good amount with multiple data centers. That's good. So redundancy is important. A little surprising on the cloud provider side not being higher. That's okay. And no one with multiple CDNs. So not at that phase for this group. So that's good. So I'll try to give a mix here of what's important about data centers as well as cloud providers, measuring CDNs as we get into the metrics of availability and reachability and how those work. So let's jump right in. Skip right through the title slide. Big problem we see with a lot of customers is they go into the status of their facilities. They are using AWS or Rackspace or someone for their cloud, and everything's green. And this is a common scenario that customers call us with. They say, the cloud's green, the status is up. We haven't had downtime in 6 months. But is everything fine? And we start to peel back that question a little bit and talk about what can be wrong. Many customers that we've dealt with, and those of you who are using the cloud today, have told us that you went right to the cloud. Never owned a server, never configured a router, went straight into using an AWS type facility, putting your application there and moving forward. And that is a sense of control that's lost, unlike going to a data center and choosing which transit you're choosing, or choosing the different pieces of equipment you're actually loading in there. So you think, well, if they're green, then I'm okay. What we actually find is there are a number of different things around the world that are happening every day that are causing different types of outages. And I classify those two things into major outages and then more regional outages. A major outage of a cloud provider or a content delivering network or a whole hosting facility going offline is very rare. They're built to be, fully redundant and everything's there. You don't see a large content delivering network 100% unavailable across the world. There's been single-digit numbers of these type of outages happen where some very bad software updates might have happened or something in the past. But they're very rare. On the whole, content delivery networks are built to be redundant and deliver content. Cloud providers are built in a way that they are available. Now, what we see more are regional outages and degradation. And the reference here on the slide talks about a glitch, and it says an AWS glitch that hit Netflix and Pinterest last month. But it actually wasn't an AWS glitch. What actually happened was AWS had that green status page. They were just fine. But certain parts of the Northeast, customers couldn't reach Netflix and Pinterest. And why? Amazon was just fine. The Netflix and Pinterest applications running in Amazon were just fine. There were no status outages. Problem was those users who were in the Northeast couldn't connect through the internet to Amazon. Amazon's choice for how they connected to different peering providers and different transit, those transit providers in the middle went out, causing your users not to get there. So you're looking at your dashboards in your NOC, and you're actually seeing that everything looks fine. But in reality, you're getting phone calls that users can't use your application. The goal of what we're trying to do here is actually help people pinpoint where these problems are so they can see, where is that finger going to be pointed? What's the mean time to innocence? How quickly can you prove it is your problem, or who do you chase to try to get the problem solved? And that's really those regional outages and degradations that are always happening around the world. This one got a lot of press, but we do see these type of degradations and outages almost every day. And they're small in scale sometimes, wider in others. They affect one provider at one time and a different one at another. So, what are the types of things that are out there that allow you to figure out the visibility that's there? Well, there's a lot of cloud monitoring tools that are out there. You can go and figure out your server performance, what's the availability, get stats on your virtual machine. You can do synthetic testing to your instance from certain parts of the world. You can use application performance monitoring tools and understand what's happening on that web page flow and what's the waterfall look like, how long is each element taking to load, what's the server response time, everything that's happening. And you can get your status out of your content delivery network. All of those application monitoring tools at this point would have shown green status in these scenarios. Right? Your application's still running. The majority of the world is still getting there. You're not seeing a problem. But can you isolate where the problems in the world really are? So we really look at this as, what's missing. And the question we're answering with a lot of our customers is, how do the customers and partners and applications reach my website, my services? So, users in the Northeast on the Verizon Fios network in Boston, can they reach where they need to? My application's running in DigitalOcean. Can my API partners who feed my application effectively reach my instance, or are they down right now from a connectivity perspective? There's really a view of this internet piece. I like to describe it as whenever we go to draw a network diagram, you typically start with a person or a house on the left. You draw a big cloud, you label it internet, and you start to label out all these different applications. You put your cloud provider, your hosting provider, your content delivery network, and we treat that internet bubble as a cloud that's uncontrollable. And this goes back a little bit to, when you make that choice to go into the cloud, you feel like you lose control. If you had built a network in your own data center or in your own facility, you would have a map of every connection between every box. You would know how the router connects to the servers and to the databases and what's backed up where. You would know the transit providers you choose. You would be able to switch between two different transit providers. Well, what's actually happening, all of that control is being moved out into the cloud itself, into the internet. But that whole internet cloud doesn't need to be a mystery. It is just a network. There are only certain paths that traffic can take between each location. Josh showed the map of this fiber interconnect. There's only so many places to go from the west coast of the U.S. to the Far East. You can go, going west or going east, but the traffic is going to flow certain directions. And what we forget a lot of times as we talk to different customers and have different conversations is each one of the hops along that network has to make a choice, and it only has a certain number of choices it can make. If you understand how the network is physically put together and what's being routed, you can put together that picture and actually draw a physical map of how the Internet's connected. It's not just the fiber lines that are connecting. It's the carriers on top of those fiber lines. It's the business relationships they have on top of it. Who do they peer with? Who do they buy transit with? How do they route traffic in any one scenario? We kind of famously describe a routing condition where if we're in Singapore and we're trying to go to the Philippines, you can see that traffic should stay within Asia in some way. But there's one provider, a large global transit provider, who always routes that traffic through Los Angeles. Why? That's the best business relationship for them. So what they've done is they've made business decisions that affect your customers. So having some insight into how is that traffic routing, how is it changing, what's happening on a day-to-day basis is really the goal. And then we look at some basic metrics to boil that down to make it simple to understand and easy to troubleshoot. So the first one we'll look at is actually availability. This is the most simple statistic that anyone can understand. Can anywhere in the world get to my application right now? And I emphasize that with anywhere in the world. So if someone can get to your application, you're available. Now, availability can be degraded. If the U.S. can't get to Europe for some reason to your application, that's a big problem. It doesn't happen that often, right? But there are situations where could be even something as far out as a natural disaster comes through and a piece of the country can't get to you. What more realistically happens is there are routing table changes, there are minor outages, there are fiber cuts in key areas that cause packets and information to be rerouted. So you see availability vary over time where certain regions can't reach you at certain times. There could be minor maintenance windows that come up that you might not have known about or paid attention to where all of a sudden you needed to do something and you have to get to that provider. So availability is just, is the service available? This is almost the green status of your AWS page. Most simple statistic. Performance, when we look at performance, we try to take a lot of the guesswork out. What we've done is we've overlaid that map of the Internet we created with all the connection points, all the routing table data where we know who should go where, and we've overlaid that with what we measure on a day-to-day basis. We take a tremendous amount of measurements every day. There's over 5 billion data points that are put together for latencies across the Internet, and we're running trace routes between the entire world to see what's happening. We take that information and create a baseline for what the path should be between two locations. So what should the latency be between LA and Boston? How does it vary on a day-to-day basis? It's not always consistent, but it's pretty consistent. So we kind of measure that almost on a 95/5 basis where 95% of the time the latency should be in this range. And then we look at, what is the variance and how does it change and how does it shift? We see these shifts happen in global coverage, and we compare that against things like the cloud providers. So if you've instrumented all the cloud providers, all the different regions and zones in Amazon, you can see, how long should it normally take for users in Miami, Florida to get to the Ashburn AWS facility zone A? And how long does it take to get there? And what does that look like? But we see that this changes over time. So if you wanted to establish strict thresholds, you would actually see some interesting trends that would happen. Here's two examples that I just pulled out of the tools we have to show how this performance can change and how watching this every day isn't necessarily the easiest thing to do on a global basis. The first one is actually the connection between Singapore and Australia. And there was a fiber cut in the last few weeks. And you can see a dramatic shift upwards in the latencies while all the paths were changed. So this is a dramatic shift. If you're alerting on this and you're trying to set up a single synthetic monitor to this location, you'd actually find that you'd be alerting the entire time until this cable was fixed. That can take weeks, even a month, maybe 2 months, depending on how bad things happen. So if you're not watching and trying to actually see what's going on around the world and understanding these shifts are taking place, you're actually having to administer a lot of the tools that should just be taking care of when performance is changing. The second is just an instance where over a few days, multiple carriers were having problems getting to an instance. So you see a shift in 2 of the 3 carriers that's happening. What we try to do is actually create that performance baseline and watch it on a day-to-day basis so we understand when these global events are taking place. And we can automatically alert and then readjust what we see as normal for Internet conditions. And we know that they're changing on a day-to-day basis. That it gives us the ability to take a lot of the administration overhead out of the customer's hands and put it into the tools to make them smarter. So when there's a problem between a part of the world and a single location, we can identify that, isolate it, and then adjust and let you know what the changes were. The next one's really an interesting concept. It's the other direction. So what a lot of our customers have asked us is, how would you identify that Netflix outage? When do you know that's going to happen? My application's fine. Amazon's fine. How do I really isolate and know to tell my support team, yes, there's a problem in New York City on the Cablevision network getting to Amazon and Ashburn? Well, you can actually do that. Reachability looks from the cloud locations to the world, where you can actually classify information and say, yes, I know that these providers in these cities are having issues getting to a certain location. We've kind of mapped the world out and identified 200 cities around the world and 600 providers throughout those 200 cities. So you have an idea of all the major, what we call eyeball networks, the internet service providers, and how they're reaching any one area. And what you can do is you can say, I know that the AT&T users on Uverse in San Francisco can't actually get to the Google Compute Engine in the middle of the country right now. They're having issues there. But in San Francisco, the Cablevision, the cable provider, Comcast users are getting there just fine. So you can actually know specifically which customers, which providers, which cities are having the problems, and be able to take actions like, okay, so the Boston users in the Fios network can't get to Amazon East, but I have an Amazon location in London. Well, it's better to take the latency hit, reroute those customers over to London, let them have the application with more latency than to not have availability. So reachability is really that reverse look from the cloud providers out to the world for what's happening. And we look at the same for content delivery networks, where we're actually looking from user perspectives. We're constantly measuring content delivery networks from real users and doing the same type of a metric, isolating those users down to the provider, the city, and the actual prefixes they're on of who can reach and who can't reach certain assets on the internet. So it's a full visibility of who can reach, who can get there, much different than an availability or performance alert. When you're looking at performance too, Josh drew the map where he was trying to take a look at specifically in the U.S. for those data centers, where were those circles of 5 milliseconds? Where could you reach? And we take a look at that same kind of information from each of the cloud providers. So this is just a map of latency. If you go in and you actually choose Amazon out in San Francisco, here's what you actually see for global transit latency to the entire world. So quickly you can isolate and say, am I serving my right customer base from that location? So the question we ask a lot to customers is really around, where are your target customers? Who is your target market? Where are you trying to reach? Are you in the fashion industry and need to be reaching New York City? Are you trying to reach tech-heavy San Francisco? Do you need to have an application that's good for people in Middle America? Understanding where you're hosting it and the penalty you're making them pay every time they're coming to the application is definitely part of the decision process for where you go next. Where do I choose my data center? Where do I choose my cloud? Which CDN performs best to this region? So, when you look at just one location, that's good. And then you want to say, well, what if I added a second location? How much better is that coverage? What should I do for market cities at this point? So giving you real tools to be able to decide what to do next and where to go. We've definitely determined, geography is an approximation for performance, but it's definitely not, the exact thing to use. There are a lot of different provider explanations, like I mentioned before with the Singapore example through Los Angeles, where there are different providers who are doing things that aren't necessarily in your best interest. So just being able to isolate down what's happening. And then also be able to make decisions if I have an origin in a CyrusOne data center in Dallas, and I have a cloud provider in San Francisco, and I'm using a content delivery network, what does this full picture look like? What is a user who's coming to my application, my website, my business, what is their performance like in my key markets? So our goal here is really to provide detailed information at the level where you can actually understand what's happening and be able to click through and isolate what's going on a section-by-section basis. So what we found as people start to use these tools, they start to bring themselves into Q&A mode. They start to be able to say, well, okay, I need to justify this decision. I'm not just going to go from the West Coast and put a data center on the East Coast. Maybe I should actually go to Europe next. you start to look at PII, privacy information type details as well. Okay, so I'm going to have expansion into Europe next. Should I choose Dublin or Frankfurt to move into? I want to be able to isolate where I keep data for certain customers. And we start discussions at this point about now how do you actually route the traffic? What do you actually do to be able to pinpoint where these customers are, understand the exact latency between points, and make real routing decisions so that you can say, yes, I want to take users in this state or more specifically on this network, or actually I want to be very specific. I want to say that users who have performance of less than 50 milliseconds go to one data center or one cloud provider, or more than 50 milliseconds go to another. And you want to be able to have failover rules in place to be able to say, yes, I know there's an issue with performance or some sort of reachability problem with data center number one or with DigitalOcean instance in New York, move them over to my alternate provider. So really playing this information to a point where you're discussing what is the performance at any one location, how does it affect or impact anything from a global perspective, isolate things down into different locations, be able to route based on this information, be able to help your support team actually analyze what's happening on a day-to-day basis. It increases the amount of information you have about how that internet cloud looks. So when you understand the impact of those deployment decisions, these are some of the key questions, right? How do my decisions impact my customers, right? First, where is your target market? What kind of customers are you going after? Who are you trying to address? Do you understand the choices with your hosting provider, your cloud provider, your content delivery network? How do they actually deliver content to the users in your target market, right? Customers come in and say, I can't control it. I chose the cloud. What can I do about it? Well, you can do things about it. Smartly start to plan out where your next location will be. Understand what your fallbacks are for failover. Understand what it means to be able to switch between two providers, stay within the same provider. What mechanisms for switching do you want? Do you want to switch just when there's availability problems? Do you want to switch when there's a reachability problem? Do you want to switch when there's a performance problem? We get the question a lot. All content delivery is the same. I should just pick based on price. I pulled a quick failure analysis of a 2-day time frame here. It might be a little tough to read depending on the viewing here, but there are certain outages that happen. The flat lines are good. The majority of CDNs over this period were performing just fine. Spikes are causing when an inordinate amount of failures are happening for an individual content delivery network. We're able to isolate in on where those failures are and give details about which parts of the world that content delivery network is failing to. So you can actually quickly make a decision, should I use CDN A if I want to expand into Europe next? Specifically, my target customers are going to be in Germany and France, or should I use CDN B? And we're finding customers searching for a lot more than price as they make these decisions. And even if you've only got one content delivery network, like most of you answered in the poll, just having knowledge about when there are problems in certain locations gives you ammunition to go back and negotiate price and be able to say, what is my strategy going forward? What is my backup plan if I want features and functionality on a different content delivery network? The bottom line, what we're trying to help people more and more do is make informed decisions. We want them to be able to look at that internet cloud and actually think of it as a network. There are people connecting to your applications and to your products and to your brand. So how do you hold providers accountable and have a plan and be able to route around information there and actually see what's going on in the internet so that you can understand where the problems are, know that mean time to innocence, that yes, I know where the problems are, I've seen them, I can tell my support personnel it's a problem in this part of the world, be aware. You can go back and make decisions about what your backup strategies are and really just be planned for where you want to be in the future and make those informed decisions. So I think now we want to transition into a few questions. I'll step off here for a second while we get ready for that.
Great. Thanks so much. We do have, it is time for our question and answer portion of the event. So at this time, we'd like to invite you, our listeners, to ask any questions you may have using that question box on the left side of your screen. And we do have some really great questions already coming in from the audience. So why don't we just jump right into them? Let's see. Okay, so let's start with this question from Yakov. So Yakov would like to know, what are the availability performance objectives for failovers? 5 nines, 6 nines? What's your opinion?
I'll take that. This is Josh Snowhorn. I actually answered it online as well, and I thought it'd be good to read it out to the audience for anybody who didn't see that. Availability for the IX in a metro is designed for 100%. The CyrusOne platform in data centers for power, cooling, and everything else is 100%. So we couldn't build a platform on an internet exchange side that didn't match that. It is crucial, though, that a customer gets a connection to both of our switches in each location, which are connected to dual or even triple optical rings. The reason for that is that a card or a port or an entire chassis might have a failure, but it's highly unlikely that both chassis or both cards would fail. So that's why we do offer 100% availability.
Great.
And I'll just take a little run at that before we go to the next one. Just if you think about that from a content delivery network perspective, so a totally different spin on the question. As we measure content delivery networks around the world, the network itself is 5 nines or more, that the network itself is always up. But we actually see that the service delivered is sometimes just 99%. And that's just based on the number of failures we measure as we test multiple content delivery networks from single users, that the user's actually getting to 3 CDNs but not the 4th one. They're completing a full suite of tests that we have out there. So we find that these are the micro-outages that are happening around the internet. And it's a much different perspective when you think about the availability 5.9 of an application and a data center like Josh has built out that is incredibly redundant and everything has multiple power and multiple access and providers. And then you go all the way down to that last mile and you think about when you have a consumer-facing application and you're entrusting that delivery to somebody else, how are you measuring it and what are you coming up with? And we're finding those numbers are nowhere near as high when you look at it from the end user perspective. So being able to flip that around as well and say, what's the availability of my infrastructure and how do I get the best performance and availability out of an individual location? And I'm going to go into Houston and be on CyrusOne. And then you have that other variable of what about my users getting to my content delivery network or my cloud? How connected is that and what's happening? It's a whole different setup. The cloud providers aren't necessarily putting in as much infrastructure, or the CDNs aren't putting in as much infrastructure as you could get out of a CyrusOne data center, right? So there are issues happening there that wouldn't be the same as running your same application.
Okay, thanks. We actually have a question here for Josh. So Josh, this comes from James, and James says, how do customers use the Internet Exchange to reach different cloud providers?
That's a great question. If you think about cloud providers, their server environments sit in various locations, either third-party data centers or their own core data centers throughout North America and really throughout the world. Those might not necessarily be anywhere adjacent to where a customer's network, infrastructure, or data center might be. They might be located in the middle of, above the Arctic Circle in some cases to take advantage of free cooling or cheap energy. There's a lot of variability with that, even in Iceland or out in northern Oregon in the high desert plains because there's very cheap hydroelectric electricity up there, things like that. So actually accessing the cloud providers requires you to access their direct connect routers. Wherever those routers sit allows you to plug into a cloud provider, and those actually still sit generally within the major carrier hotels throughout North America and throughout the world. It's just logical for those cloud guys to locate that because of the multitude of networks coming in. So to answer the question, the Metro IX and even a National IX product allows access to any of those facilities for any of our customers with complete diversity and resiliency. So I answered the earlier question with 100% SLA and uptime. If a customer gets those two connections onto the IX platform, say in Dallas, and they want to reach Azure, Office 365, AWS, Rackspace, SoftLayer, any of the multitude of cloud providers out there, they're able to easily do that with just a cross-connect within that carrier hotel, and all we do is carry them on our redundant platform at really only the cost of a cross-connect at each end.
Great, thanks so much. Okay, we have a question here from Charlie, and it comes from Pat. So Pat says, cloud and CDN insight are good, but what kind of insight can be gained about mobile networks and my customers using my mobile applications?
Sure. So it's interesting. When we try to characterize the data that we collect, we're actually breaking everything down and labeling each part of the information. So because we're understanding that map of the internet and how things are routed and how it's classified, we actually break all of the measurements we take from the Earth to a continent, to a region, to a country, to a state, to a city, to a provider with a prefix. So we're able to actually isolate the information down into, what kind of network did it come from? Did it come from Verizon Wireless? Did it come from Verizon Fios? Where was the origin of that information actually measured from? We know a lot about the DNS side of the world, right? About how to route traffic there. So, what recursive DNS servers are actually making requests for that content. So you can break the data down not just into, is it a cloud provider, is it a CDN? When you think about how it's impacting your subscribers, those subscribers can be broken into parts of the world where you're isolating geography and carrier to be able to break out mobile and actually give a good representation of the difference between a mobile network performing to a content delivery network or to a cloud provider or your data center versus a fixed line asset or a part of the world that's doing the same.
Okay, great. Thanks. We're actually coming to the quarter of the hour. So why don't we take one more question and we'll let everyone get back to their day. So we have a question here from, I think it's Sylvester, and he says, so interesting, cheap price shouldn't be an issue when routing and pinpointing with feature and functionality rather than performance and consistency and measures through all systems. It's a sort of a statement, but I guess he's asking, does price matter?
Sounds like that's something for Charlie. Yeah, sounds like it's you.
So you would think that price shouldn't be an issue, but more and more we see the first decision being made on price. And I think part of that is the commoditization of content delivery in cloud instances where the decision matrix of somebody going into an individual provider aren't necessarily based on a lot of information. So if you leave those decisions up to different levels of an engineering team or different people in the organization, you may find that they choose a location, they start developing, and that decision of choosing a development environment grows into the place where the application is actually hosted without much thought to any of the issues we talked about today. So price becomes the first factor of I just need a VM to go run my Linux instance and start building this application. Grows into, wow, a critical part of my business is now hosted at a cloud provider that I didn't really intend to be at. So I agree, it shouldn't be a major consideration. It ends up kind of falling out of other decisions. As price drives down, I think it'll be more and more important to say the functionality is equivalent across these providers. What really will give me the best situation for my target market, my target customers.
Great. Well, you know what? We are out of time, but why don't we just, if it's okay with you, Josh, just take one more question, and then we'll let everyone get back to their day.
Sure.
The question here comes from Amanda. Amanda says, does the IX platform help with active-active or active-passive replication or replication between data centers?
Oh, absolutely. So, but what CyrusOne has done is pre-placed massive interconnection between our data centers, especially in low latency markets. So, for example, between Dallas and Houston, or even pushing the edge of latency, Dallas to Houston, we're able to put in high-speed circuits at 100 gig, 10 gig level, anything a customer could want. As I said earlier, over 60% of our customers take multiple data centers, and most of that is for active replications. That's 2 large multi-megawatt environments, for example, in both of those major cities, and they might even have a third passive location in a different power grid market like Phoenix or Ohio. And that really meets their entire portfolio needs from an enterprise perspective. Once that's in place, they just scale that up and continue to grow organically within CyrusOne or with other partners and vendors. We do have other competitors we even get links into to make sure we facilitate a good connectivity story for a customer. So the IX is crucial for that, and that market intelligence we bring in with Dyn and then put together with our own staff internally at CyrusOne on the fiber mapping side creates the perfect resilient solution for all of our customers.
Well, thank you both. Excellent presentations, both of our speakers. I am afraid, though, we are out of time. So I'd like to thank everyone for joining us today for our special presentation, Understanding Availability and Reachability in the Cloud Age.